we have y equal to sigma n equal to 0 to infinity Cn x power n. We write this series about x equal to 0. When its right expansion is C0 plus C1x plus C2 x square plus C3 x cube plus C4 x to power 4 and plus so on. When I differentiate this one, I get you y dash. This is, I can write this equal to C0 is equal to 0 and get here C1 plus 2C2x plus C3x square plus 4C4x to power 3 and so on. Now if I take here y double dash, so y double dash is equal to, then C0 becomes 0, we get it C2 plus 3 into 2 C3x plus 4 into 3 C4 x to power 2 and so on. We want to write the summation form. Summation form will be from 1. So sigma n is from 1 to infinity n Cn x to power n minus 1, and here is sigma n is from 2 to infinity. We are having here n into n minus 1 Cn x to power n minus 2. So this is the idea we have applied. We just do it in the beginning, we do it again. Now we substitute the value of y and y double dash in our differential equation. We get here sigma n is from 2 to infinity, n is from 2 to infinity. We're having n into n minus 1 Cn x to power n minus 2. This is y double dash plus lambda square Cn. This n is from 0 to infinity Cn x to power n equal to 0. So as I mentioned last time that in this equation with the coefficient there is no coefficient which is x. So we don't need to take anything inside. So here next is that we want to equate the powers and this summation. So I just rewrite it. We're having a sigma n is from 2 to infinity, and it's from 2 to infinity. We're having n into n minus 1 Cn x to power n minus 2 plus lambda square sigma n is from 0 to infinity Cn x to power n equal to 0. So here, as I mentioned before, what we do, we are going to change this n minus 2 to m, and here we change n to m. So now we are the values of the summation will change. When n is equal to 2, we get here m equal to 0. When n goes to infinity, we have m goes to infinity. Here when n equal to 0, m equal to 0. And when n goes to infinity, then m is also going to infinity. We make these changes and get to the new equation sigma. Now n equal to 2 mean m equal to 0. N equal to infinity mean m equal to infinity. And here we get the value of n. What is the value of n? N is equal to m plus 2. So we are having here m plus 2. Then we are having m minus 1, that is m plus 1. We take here minus 1 out. Cn, n is m plus 2 x to power m. Then we have plus sign here. We write here the second term. Second term is lambda square. We have sigma m is from 0 to infinity, and we get Cm x to power m equal to 0. Here is the summation in both the cases. This is from when m is equal to 0. So we have summation out, we have expound, we don't need to do anything to make the summation equal. We are lucky, we are getting the result immediately. So we take here sigma common, where sigma m is from 0 to infinity. Inside I'll get here m plus 2 into m plus 1 c m plus 2 plus lambda square Cm x to power m is equal to 0. All the coefficients right hand side are equal to 0. We compare the coefficient of x to power m. We get here m plus 2 into m plus 1. We get Cm plus 2 plus lambda square Cm is equal to 0. And we have the value of m is equal to 0, 1, 2, 3, and so on. This is my recursion relation. Recursion relation. With the help of this recursion relation, I'll get the values of C's. Now we can see here our equation is of order 2. So we get here two arbitrary constants. Let it be C0, and we can write the solution in terms of C0 and C1 because they are arbitrary constant. As I showed the order of differential equation, we get the same number. Last example, we have first order differential equation, we get one arbitrary constant. Second order differential equation, we get two arbitrary constants. We get from here. This means we will find the values of C's, and then we substitute the value of C's in this equation, and these values will be in terms of C0 and C1. So I rewrite my recursion relation. I'll get here my value of Cm plus 2. Taking this term to the other side, we get minus lambda square. Divided by the coefficient, that's m plus 2 into m plus 1. And we have the value of m is equal to 0, 1, 2, 3, and so on. Now we are in position to get the values of C's. We take here m equal to 0. We take m equal to 0, we'll get here C2 is equal to m equal to 0, get minus lambda square, this 2 must be above, more visible, minus lambda square over 2 into 1, then C0, we're having m0 is equal to C0, C2, m equal to 2, m equal to 1, C3 is equal to minus lambda square, is not changing. Then we having here m equal to 1, we get 3 into 2, is 3 into 2 C1, and we're having m equal to 2, we get C4 is equal to minus lambda square, 4 into 3 C2. I can write similarly C5 is minus lambda square, 5 into 4 C3. So we are having a rhythm here. We can get here C2, C3, C4, C5. Now we can see this one is equal to minus lambda square over 2 factorial C0. I put the value of C0, and I can have the coefficient, three coefficients are my C0 and C1. Then it's become here C3 is in terms of C1, and we can have here this equal to minus lambda square 3 factorial C1. This is here the values in terms of C0 and C1. So put the value of C2 here. I get here minus with minus plus, get here lambda to power 4 over, we're having here minus 1 to power 4 is equal to plus sign, and here 4 into 3 into 2 is 4 factorial C0, and then here now we're having minus lambda square C3. C3 is minus lambda square, minus and minus become plus, and I'll get here C to power 4 over 5 factorial. Here is 5 into 3 into 4 is 5 factorial. We're having C1. Now I'm having C6. What's my C6 is minus lambda square, 6 into 5 C4. What's my C4? My C4 here is plus sign, this minus sign, so remain minus, lambda to power 6 or 6 factorial C0. My C7 will be equal to minus lambda square, 7 into 5 into C5. Which is my C5. Plus sign, this minus, so get here minus lambda to power 6 over 7 factorial is 7 into 6 here, and C1, and so on.